in Rust. Stay with me. Okay. So if you really want to understand it, stay with me. Um, so first of all, if this is your first time of coming across this profile and this channel, yeah. So my name is Victor actually, and um, I'm a back end engineer, right? I don't want to say I'm a full stack engineer. Um, yeah, I'm also a full stack engineer, but I majorly focus on the back end and the infrastructural aspect of um, the internet, actually, generally. So I focus more on infrastructural and back end. So using Rust language. So Rust language has been my favorite, my primary go-to language in the past few years, actually. So yeah, I also write TypeScript, by the way, but that's just a brief introduction of me. Um, so before we go over to understanding specifically what ownership is actually and Ross. So first of all, I want us to read this post together. And yeah, this is a post I made yesterday on LinkedIn. All right. So I just want us to read it together. So it says that so this was talking about a job, a contract I got actually, which was a Solana escrow project. It's that because of the NDA that was signed on this, I made a post about it to document my journey on LinkedIn, but the NDA I signed actually reached out. So the company reached out to me and told me that I will not actually go ahead and do this documentation. So I have to update, right? Do an update because people will be expecting, okay, for me to maybe share how I built it, what happened, all this whole process. But I didn't later. So this was just an update telling them that I was restricted from it, right? And currently I've been building a product actually called Asums, right? So I just want us to read through what it does, right? And just stay with me, okay? So we still go back to understanding ownership. So this is it. Um, so this says that for a while now I've been working on something deeply behind the scenes actually. So a durable execution layer originally designed around Solana transaction flows, right? Please stay with me. I know that you know reading is this thing might be boring, but it's really be it really bless you at the end of the day. So for a while now, so this I've been working on this actually. So it's a durable execution layer, originally designed around Solana transaction flows. So the original design for this product actually was just execute transactions, right? And for launch, we are targeting only Solana, right? And also the idea behind it was just for it to be an execution flow that actually doesn't there is no silent error, right? Because when it comes to transactions or when it comes to workflows, right? Most tools that are existing currently now doesn't actually know anything about um, auditing because there is a lot of silent failures that happen behind the scene that they don't pay attention to, right? So this is one of the things that this platform tackled, and also it also track off chain states. It also has retries, replay, dead letters, idiopotency, and all those um, features that makes a system reliable, right? So that was the initial flow, but along the lines, I go deep into building this tool. Actually, I found out that I have to niche down a bit, right? And so niching down was that I needed to just focus on fintech. I don't like calling it fintech because it sounds weird to me, but it's what it is actually. But it's more on the infrastructure aspect of fintech, right? And what the new version is, what it evolved into now is that is a tool that actually handle transactions, right? Because okay, so this sorry for actually talking a lot. So let's read down actually. I said here that the execution alone is not enough, especially in financial system, because in real systems, retries duplicate money actually. Providers fail unpredictably and state becomes inconsistent at the end of the day, which is stuff that happen normally. In fact, here in Nigeria, it happens often. Filter wave, paystack, money points, name them, right? Paper, OP, stuff like that. So the system evolved actually. So it's no longer just about executing transaction actually. So it's about controlling how they execute, how they fail, how they recover, and how they are verified. So, talking about the verification now, we actually integrated reconciliation and exception indexer into this platform, right? We are still working on it actually. And so, what it does generally is that it just helps in verification, because what the execution layer does is just to track what is happening, but the output of the execution with what we intended for it to do, this is where verification comes in. This is where the reconciliation comes in, that matches it and classifies it, right? So this is where this thing evolved into. Let's read down actually. So I introduced two major layers actually, which was actually the reconciliation layer. This verifies that what would have happened actually did happen. So no logs, no assumptions, but deterministic state comparison. The intelligent exception indexer. So instead of just logging failures, the system indexes anomalies, classifies inconsistencies, make them queryable, which is a very architectural design, very good architectural design. So um, failures are no longer happen; they are structured, right? Sorry, it's not happen. They are not hidden actually. They are structured, which is one of the core fundamental of this product, right? And then I added something even more interesting, an AI as a control execution interface. So this AI layer I added to this product is not like the AI is what will be executing the product. No. So the product is structured in a way that um it is independent, right? They have, it has strict boundaries, right? And the execution is logical, and there is no AI of anything attached to execution. So where the AI plays a role in this platform is that, so let's say that there are systems that actually run transactions via AI, right? Where maybe AI can refund, can generate invoice and make payments, right? And a lot of systems don't want to really give AI full access to their workflow, because of um whatever risk. Actually, there are a lot of risk attached to it, right? So what the AI integration does is just that when systems that use AI comes to this platform, they what they have to do is just to they register their AI agents, right? There will be an ID registration for AI agent, and what the ID does is just that when an AI wants to execute, so this system sits between your AI agent and the engine that wants to execute, right? So when the AI wants to execute, the system we have to verify that this AI that wants to run this that wants to do the refund or generate an invoice is the right AI that should do that, right? And a temporal access will be given to this AI to do what it wants to do, right? And let's say for any reason, and there are strict policies are also attached to this workflow, that maybe let's say AI cannot actually refund a transaction beyond $300. So anything beyond $300 or $1,000, we need a human verification, right? So this is how it works. So when when an AI wants to maybe refund a transaction above 300 or 1K dollars, right? A notification should be sent to maybe an admin or whoever, maybe via Slack or Telegram or Discord. This part now, I have this integration of Slack or Discord have not really been integrated yet, right? So what they can do is just to click accept or allow, and the whole process will allow, right? So that's the function of the AI to I said here that the request, what the AI doesn't execute directly. Actually, what it does is it requests action or press under strict policies gets limited and temporal access and requires human approval for sensitive operation, which is what I really explained here. Right? So it becomes a durable, auditable execution layer for financial system usable by both APIs and AI. So at the end of the day, this is both for Web3 and also because I mean Web3 generally is a transaction state, is a transaction state system, right? And then for the Web2, the traditional financial system, we want to start with Stripe, and the part you want to go with Stripe is the refunding system, right? So this is just basically what this post is talking about. So when it comes to building reliable tools, things that actually work under failure, right? Failure happens at the end of the day, but when it talks about things, this thing must work under failure. No matter the failure that happens, we expect that this thing works. This is how I actually work around executing, and this whole the back end totally was written or is still being written in Rust language at the end of the day, right? And the UI is TypeScript. So I'm writing both the front end and the back end, right? So I'm using AI mostly for the front end system, to fasten my workflow because I don't want the UI to be when you want to know the design. Oh Jesus, is a lot at the end of the day. So yeah, that's that for this. And yeah, tomorrow also I'll still talk about another post that addresses what I'm currently building. So the idea behind this is just to come on my LinkedIn, talk about a post I made actually. So that's just how it's in this period. So, but now let's go back and talk about our ownership in Ross. So let's see if we can understand what ownership means together, right? So that's just our goal. Okay, so first of all, let's go to the documentation here. So this documentation is said. So this documentation said that ownership is a set of rules that governs how a Rust program manages memory, right? So all programs have to manage the way they use computer memory while running, right? So this is basically what ownership means, right? So it's a set of rules that governs how Rust manages memory, and so when we talk about the stack and the heap, right, I just want to um, give us a rundown about this. So, um, the stack and the heap are all memories at the end of the day, right? But now they are different in different ways, right? So, the stack is actually a much more organized way of storing data, and the data must be known at compile time, right? And also um, when you talk about stack, it's just like you're stacking plates on top of each other. That's how it is being arranged in the memory, right? And so you can pop off it from the stack, you can push to this stack, just and the slang is just that first come, um I think last come first out, right? I want to find it here. I think that's the slang. Okay, so I can't find it. Can't find it. But the way it works is that the same way plates are stacked on top of each other. So if you want to take the plates that you want to use and maybe serve somebody food, you go from the top. You will not go from the middle or from the bottom. It doesn't work that way. And the heap memories are just memories that um they are not fast, right? Stack memories are faster than them. If you want to fetch or you want to push or you want to pop data from the memory, stack memory is more faster than the heap memory, right? But the heap memory works when the data or the input is not actually known at compile time. So for example, when maybe there's a system that actually gets someone's input, right? It gets someone's input and have to now program it and gives us process it and give us a good output, right? The input is not really known at compile time. That's when heap memory comes into play, right? And when you talk about ownership, heap memory is the major focus of ownership actually in Rust language. And so there is one thing that you have to know. We still come in the code aspect of this thing actually. So there's one thing you have to know in the heap memory, right? I'm sorry, in ownership rules, and when it comes to heap memory, is that um there cannot be two pointers. That reminds me. So let me explain what a pointer is actually. So when data are stored in the heap, right, the address of the data is being stored on the stack. Why is it being stored on the stack? Because it is known at compile time, right? The address of the stack of the heap data has three categories: the length, the what is pointing to, and I think the capacity, right? Let's check it out. And yeah, that's so. Let me give a vivid example. So let's say you came to a restaurant to book a space for allocation, right, for you and your friends to hold a party or whatever, right? At that point, at that point, um, you meet the receptionist and you tell the receptionist, okay, this is how many we will be, or this is what we're expecting, right? This is the range of what we're expecting, right? And the receptionist will go and find a space for you people, and maybe you're the only one that have already come for the event, right? So next time, somebody comes to the receptionist, what the receptionist have to do is just to direct the person to the location you are already sitting, because the receptionist already have an address of it. So the person comes, okay, this is the event, right? This is how many people we are expecting. Yeah, is enough information to direct the person to the right memory. I mean, this is just a vivid example of how it works, right? But it doesn't mean that you, but technically that's what it means, right? And so when you talk about heap, actually, so Rust is strict on actually what is it called, double freeing in ownership rules, right? Double freeing, and double freeing just means when you're trying to free up a space in the heap twice, right? So ah but let's talk about the rules of ownership. So these are the famous rules of ownership, right? Each value must have an owner. There can only be one owner at a time, and when an owner goes out of scope, the value will be dropped. So, and so when you talk about a value going out of scope, so this is what we talk about. So scope can be defined as the range within which an item remains valid, right? So this is what it is. So let's try go to our code base and write something. It's equal to okay, so this is it. So this is the scope of this code, right? This is the scope. So if this s goes out of this scope, it can never be valid again, right? Let's say you want to print this thing outside of this. Let's say you just define another function. I want to print this outside of this group. In fact, let's just make it to uh, let us make this much more interesting at the end of the day. So so let's say let y equal to world. Okay, so Okay, so now this why this value is only valid at this point. So when we say that each value in rows has an owner, right? And this is what you mean. So that means that this is a value world and this is the owner y, this is a value hello and this is the owner s. So each value in rows has an owner, must have an owner. That's one. So there is no orphan value or there is no bastard value in Ross code actually. So that's one. And when we say that there can only be one owner at a time, so that means that each value each value in Ross has only one owner. One person, one owner, or one value can only have one owner at a time. So that means that so that means that this so that means that one value, this is a value and it owes this, right? And this is another value and it owns this. Let's try and print this and see what happens. Um, okay, so word was printed, right? So this is it. Word was printed. So then when we talk about how you keep on forgetting. So let's talk about this. Like when owner goes out of scope, the value is dropped. So and automatically Ross calls the drop keyword actually. Uh, yeah. So let's try to print this thing out of this scope, right, and see what will happen. I find the, I think the yeah the Rust compiler is already frowning on this, right? So this is the rest quickly line saying that this isn't what should happen. This is not a normal. Um, so this is what it's saying. So the binding y is available in a different scope. So immediately this y crosses this line, right? The value is dropped. It's no longer valid. Right. The only valid code here now is this s. That means if you call this s here, our compiler will be fine about it. And so this this is just a basic, very basic explanation of you understanding what ownership is in Rust. By the way, I really made a very detailed video about ownership in Rust in my YouTube channel. So if you need that, you can go to my YouTube channel and just pick it up. Actually. Yeah, there is a detailed video about ownership actually in Rust language. So I think I made that video last year, right? So, but this is just a brief explanation of what ownership looks like. So yeah, so this is when two strings data stored in the heap are trying to point to one data, and so like I said before, right? Um, like I said before, so this ownership rule, there can only be one owner at a time.